Hello friends, welcome to engineering tutorial. So this is the 7th question that we are going to discuss on diode connections, questions related to diode connections. So we have this circuit here which consists of a 10 milliampere independent current source, two resistors 2.2 kilo ohm and 1.2 kilo ohm, and a silicon diode. And it has been asked to find this output voltage across these two terminals, and there is another parameter here which is this current. It has been asked to find. Now all of this discussion, it revolves around one important thing here. How is the behavior of the diode? What is the state of the diode, whether it is on or off? So everything depends on that. So we have to determine the state of the diode. So here, if you notice, this 10 milliampere current source and this 2.2 kilo ohm, they are connected in parallel. Okay, it is connected across this 10 milliampere current source, this resistor. So we can use source transformation rule to convert this current source into voltage source. We know source transformation, we have discussed in circuit theory. I have also posted a video related to that, you can check it out. So we can convert it into a voltage source by multiplying. This will be 22 volt. 10 milliampere into 2.2 kilo ohm, 2.2 into 10, 22 milliampere kilo ohm, they will cancel each other out. And this resistor, it will be in series with it. This will be the transformation that will happen. Okay. Now here let us assume that this diode is on. Okay, we will assume that this diode is on here. So we will replace it with its equivalent circuit. Here there has been no mention about any forward resistance, so we will replace it with its barrier potential or built-in potential, which is 0.7 volt. And then we have this resistor 1.2 kilo ohm. This is the output here. This is the current. Now if we put KVL here, we will get 22 minus 2.2 to ID minus 0.7 minus 1.2 to ID is equal to 0, or that implies we can write this current as 22 minus 0.7 will bring all the ID related terms together. It's minus 2.2 minus 1.2, which is 3.4. So it will be 2.2 plus 1.2, let's say. So it will be 22 minus 7, 21.3 by 3.4. So let us calculate what value will be. So will be calculate, it's 6.26 milliampere. Okay, it's in kilo ohm, so it will be in milliampere. So ID is 6.26 milliampere. Okay, so now this is positive, and this current 6.26 milliampere is flowing like this. Or we can say that this is like this it is flowing. From P to N through the diode. So when a current flows through P to N through the diode, it means that this diode is forward biased, it is on. It means our assumption that this diode is on, it is correct, and all these things associated with it are also true. Okay, these relationships, they hold because our assumption is correct. So here this current ID is equal to 6.26 milliampere. V out, this output voltage, is simply this 6.26 milliampere, that is ID, into 1.2 kilo ohm. Now that is equal to how much? Let me calculate. So it is coming around 7.517, no, 7.52, okay, 7.517 volt, or nearly equal to 7.52 volt. This is the output voltage. So here again, like in all the diode connected circuits, first the behavior of the diode is important. Another important thing here is this source transformation. The source transformation simplified the circuit. Otherwise you could have used nodal analysis also, but applying that here would have been a little bit complicated. So converting into a voltage source, it simplified the whole circuit. Otherwise you would have to apply two nodal analysis here, one at here, another one at here, two equations, and it would have been a little bit difficult. But when we converted into a voltage source, this got easy. Okay, first source transformation, then determining the behavior of the diode. We assumed that the diode is on, replaced it with its equivalent built-in potential, found out the current. It is positive, flowing from P to N, so our assumption is true. This is the diode current, and this is the output voltage, the voltage drop across this 1.2 kilo ohm. So this is the 7th question which we have discussed. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.